when I'm doing a division of a polynomial, when I'm dividing by x plus 3 here, I'm looking to see if x plus 3 is a factor, which is the same thing as me looking to see that if negative 3 is a root. And when I do synthetic division, I'm actually dealing more with the roots. Okay, so that's why you're seeing a negative 3 in this position over here. This is my divisor. And in synthetic division, we make use of the root, the potential root, so to speak. The 2, negative 7, and 15 are coming from the coefficients I have in my polynomial function. Another thing that needs to be mentioned here. If that polynomial function had like a missing power of x, any missing power of x would have a coefficient of 0, so zeros would be placed in for those missing values. It's not happening here. We have 2x cubed minus 2x squared minus 7x plus 15. So I have all the powers going from 3 down to a power of 0 on my x. That's the constant term. Nothing missing, so I just put the coefficients in. But if there's any missing powers of x, I have to put that 0 coefficient in somewhere. And here how I carry out the synthetic division is by doing this. I first bring down the first number. That's on that side too. When I have a number appear below this line, I'm going to multiply that to the negative 3 or whatever is in that area where my divisor is, and I multiply them together, and I put that number underneath the next number. And here's another fundamental difference between synthetic division and what you're used to doing with regular long division. I now add the two numbers together that I have now. Negative 2 plus negative 6 is negative 8. I now have a new number that comes below the line. So that new number gets multiplied to that negative 3. And of course, negative 8 times negative 3 is 24. And I put that underneath the next number. And now I add these together. Negative 7 plus 24 is 17. A new number is now below that line, so negative 3 times 17 is negative 51. I add those together, and I get a negative 36. So with polynomial divisions, you can actually get negative remainders. It is possible. You're not used to seeing that with regular division. Therefore, if I want to state what the quotient is for this, negative 36 is the remainder, whatever ends up in that last little half box over there. The one that immediately to the left is the constant term. The one that's to the left of that is the x term. The one to the left would be x squared. If I had more, the one to the left of that would be x cubed, x to the fourth, working my way from right to left. So I would say this is 2x squared minus 8x plus 17 with a remainder of negative 36. But what we often do with that, we kind of go back to our fraction day and say, well, remember when we got a remainder, that's what we would put over the original divisor. And the original divisor here was x plus 3. So I could say this is the same thing as me saying 2x squared minus 8x plus 17 minus 36 over x plus 3.